All right, hello everyone. Thank you for tuning in. Um, Today I'll be making a video on how branches work in LC3. So a quick introduction. I want to state for those that don't know or you guys are getting new into LC3. So load, what it basically does is basically stores a value. So using this label, we could store these values. So we have decimal zero, we use fill. And then we use decimal zero, and then we use decimal 12 to do 12, and so on. And these labels are pointers, which will basically point down to our local data and store these values using the load instruction into our registers. So in this case, we have registers 1 through 3. Very simple and pretty straightforward. Now, we have our branch statement right here on line 11. However, it's very important to know that it's associated from 8 through 11. So what this essentially does, it called it loop multiply because it's basically doing that. So we have R1 as R0, and what we're doing is, we have R1 as 0, and what we're doing here is just basically adding R1 plus R2, which is 12, right? And then we're assigning that value, that result, into R1 again. And what you're probably saying is like, oh, well, I thought we stored R1 with 0. And yeah, that's true, but in this case, we're multiplying. Well, actually, I'll get to that point shortly. So we have a result in R1, right? And then we have line 10, which is just basically R3, which is 0, or R3, which is 6. And then we're subtracting that by 1. And then we're storing that into R3 again. So in this case, I think you guys could know what's going on at this point. And then line 11 is going to check the line above, which is R3. It's going to check register 3, and it's going to see if it's positive or not. If it is positive, it's going to go back up to here to line 8, and it's going to repeat the same process all over again. So essentially this is a for loop in LC3. So as long as it's positive, it'll go back up here and execute. Otherwise, it'll just go down sequentially to line 12, right? I typed that for no reason, but it'll just go down like this, right? And then it'll end the program. So I could prove this to you if we go to assemble this. And another thing I want to point out, actually, I'll state the technicalities after, but let's do this first. So we step over, now we're inside our branch, or for loop. Sorry. So now we're inside our for loop, right, at this point. And I also added this halt instruction because if I didn't do that, it would just execute the whole entire thing and it would hit halt, which basically ends our program, and all of our data in our registers would be gone and overridden with some random garbage number that we don't want. So we step over, we have our first iteration complete basically. So let's just do that. Now it's completed. We have R1 is 12, which that is true. We added R2 to R1, and then we subtracted R3 by 1, which we have 5. Now we're going to go back up because R3 is still positive. So we go here and we do the same thing. 24, 4, 36, 3, 48, 2, 60, 1, 72, 0. At 0, however, that's not positive. 0 is not a positive, it's just like 0, you know? So it's gonna be done after that. It's gonna go down to halt. It's not gonna go back up here anymore. And yeah, that's you. We just did multiplication in LC3. 6 by 12 or 6 times 12, and we have 72. So it's very unique. It's not like your higher level languages like C++ or Python. They make it very easy to multiply. This is more cumbersome, but that's how it is in LC3. We're only working with 8 bits. That's why we have 8 registers from 0 to 7. So we're very limited what we can do, and that's why we can only use add when we want to multiply. So when we multiply, we use add. We want to subtract, we use add. So it's kind of counterintuitive, but it makes sense. Um, because we could also, what we could do is we could store a negative number. Um, so what I could do right here is do load R4. Let's do that up here actually. Load R4, load R5. Oops. And then we could do this decimal 2, and then we have decimal negative 1. Let's call it negative. Do this. Okay. Then we have so we have that, right? Now we can do sorry about that. So now we could do decimal 2, decimal negative 1, and now we could do this. Add R1, or sorry about that. We could do R4, R4, R5, and now we assemble that. And now we have R4 is 1. Remember, R4 was 2, and now R4 is 1. So that's how we subtract in LC3. Very weird, but it works. Um, Same works for division, or never mind, it does not work the same for division. It works a little bit differently. Um, but it's the same routine. I'm not gonna go into it. Um, Divide, use add. So to do every operation in math or basic operations, we always do add. So to go back to the branch, got off topic, but to do branch, we basically want to do negative 0 positive. That's the instruction in LC3. So if I go here into the instructions for branch, right? We have NCP, and it needs to be in that order. So it could be either Z, it could be N alone, or it could be P alone. But if you want to use all 3 of them, it has to be in this order. Otherwise, it will not recognize that instruction because that instruction does not exist. It could be ZP, it could be NP, it could be NZP, but it needs to be incremented, right? It needs to go from low to high. And then we have our PC offset, so we have an immediate value of 9 bits. Um, This whole instruction list is very technical. A lot of people like to use this, but don't go into the code for some reason. I don't know why. However, sorry about that. If I go back over here, we only use the P instruction, but make sure that if you use a branch, you want to know how um, you word it. So just to reiterate everything I just said for branch instruction, we have our 3 numbers, we have our initial label. If this is true, it will go back up here and it'll do everything inside from lines 10 through 11. Otherwise, it will just increment past. it would just keep going down sequentially. Another thing to keep in mind, for the add instruction, see how I have a -1 and why I didn't do, um, why didn't I do it like line 10? That's because I could hard code it like that. Um, and I could do that for as long as I'm within 5 bits. So if I go back to the add instruction, there's two adds. One of them is immediate and another one is register. The first one that I used is, oh my God, the first one that I used is the register add. The second one here is the immediate add, and it needs to be an immediate value of 5 bits. So if it's not within 5 bits, otherwise my range is from -16, ps- -16 to +15. If I go past or over, or if I go below those or higher than that number, from -16 to 15, it will not work. I will get an error. So if I do this, boom, cannot encode a 5 bits to complement this number. So that's basically telling us, hey, this we want this, and you're giving us some range that's just not possible, and it won't work. However, uh, with add instruction, with the add instruction, with the add register instruction, sorry, I'm very tired, but with this one, that will not be the case. You could have a number that's pretty big and it'll execute. I'm not gonna go into the details. It's a lot of explanation for one video, but that's basically how it works. So yeah, now you know how to multiply in LC3 and you know how branches work in LC3. Thank you guys for watching. Let me fix this before I end the video. Thank you guys for watching. And I hope you guys have a great day.